Okay, I think we're live. Hello,
Yes.
everybody. Welcome to CosmWasm by Dummies. We've already got some people in the chat. Hello, everybody. Gritz's
Look at
body is
this.
ready. That's good to know. Remember to hit the like button if you haven't, and don't forget to subscribe for more. Thank you, Grits.
Already hitting the call to action. We haven't even covered anything.
Okay, so, oh gosh, my terminal is very small. I'm going to increase my terminal size while Callum tells everybody what this is all about.
Yeah. So we noticed there was a post on Commonwealth at roughly the same time that this idea was birthed. And we noticed there's not really that sort of onboarding for developers or any sort of content that covers sort of developing or getting involved or sort of just a Q&A. And we felt like a lot of people could benefit from this while we just probably get sidetracked a bunch as well. So yeah, basically we spun this up to sort of help onboard people. They can come in, ask questions, might do some live coding eventually, which is always a recipe for disaster because as soon as anyone looks over anyone's shoulder when they're coding, any sort of coding knowledge is gone. So yeah, we have some questions collected from Twitter, Discord, all of that. But if anyone wants to ask something, just put it in the comments and we can get around to that as well.
Cool. Okay. Shall I go? I've got the spreadsheet up. So shall I ask? Shall I start going through the questions?
Yeah.
So the first one, very topical for our first episode. What previous knowledge is needed to learn CosmWasm? I think Callum, you've come into the ecosystem a bit more recently. So would you like to take that one?
Yeah. I'll go for it. So
don't say a computer science degree because
no,
that's
you don't need a degree. You don't need a degree, but you probably should have some technical know-how with programming before, and that doesn't mean you have to be an expert at it, but don't go into it not knowing how to write an if statement or a for loop because you'll just get bogged down in the boilerplate of this sort of thing. But you'll be like, I have no idea. You should be familiar with Rust, and that's great because Rust is a normal language. So there are great courses on Udemy, YouTube. There's like crash courses where you can pick it up quite quickly, and you can just then go in. I'd say Rust is a definite baseline knowledge, but if you don't know Rust and you're like me, but you are proficient in other languages, you can kind of pick up Rust as you go along with CosmWasm. But that's if you feel confident, if you're sort of already confident with programming. But there should definitely be that sort of baseline of knowledge.
Yeah, Rustlings was what I used initially, coming from a grab bag of various languages. I was just like, I want something to just run in a terminal and mash away at until I understand the basic syntax. And yeah, Rustlings was quite decent. We'll put some of these links in the show notes, but equally, if you Google Rustlings GitHub, you'll find it on there. And you can run it interactively and muck around it with your Terminator with your terminal. Don't know where that came from. I guess other prerequisites maybe outside of the programming language. Anything in Cosmos, it pays to have a bit of an understanding of how the Linux command line works. If you are on Windows, you'll want to be using the Linux Windows subsystem. Otherwise, you're probably going to have a bad time. If you're on OS X, you're done. Well done. It's basically a slightly friendlier Linux. And yeah, the people on OS X can have no problem. People on Linux can have no problem. People on Windows, you won't have a problem if you get WSL running. The final point, I guess, while we're talking about command line, and before we go on to like installation stuff, is that because of fun reasons involving WebAssembly and the upstream library, until very recently, it wasn't really possible to run on ARM chips, and it's still not possible to run production CosmWasm chain, sorry, on an ARM processor. So you're also going to have an easier time if you are on Intel, although now both Juno and WasmD ship with an ARM compatible dev mode if you run it in a Docker container. So when we get into doing Quickstart stuff, we'll be showing you how to do chain Quickstart, doing everything in Docker.
Yeah, exposure to Docker is probably also another point to add here. You should probably be aware of Docker.
Yeah, but then I think if you're not aware of Docker, I think all you need to really understand is
You just need to run that command when you
it's
want
a
to do
build
this.
tool.
Yeah.
It's a build tool, and if it does weird stuff, you might have to Google a lot of commands with the preceding word Docker as you go to work stuff out. I guess the final prerequisite for this stuff, which is really, it's not previous knowledge so much as previous attitude, is just I suppose the confidence to bash your head against something until it becomes clear what the solution is, and probably like so a certain amount of determination and kind of gumption, if you like.
Be prepared to have to seek out. It's not like other programming language where you Google, oh, how to reverse a linked list, and it's their first result, copy paste, boom. This is, you're going to have to be a lot more involved. It's a tighter knit community, and the docs aren't particularly, well, they're not as mature as say any other language, because it's just not the nature of things, because it's been being actively developed. But you're going to have to seek out communities such as the CosmWasm Discord. The Juno Discord is great. Frey and I plug away when we can in there. But so you need to have that mindset where you need to be able to go out seeking and just not get burned out and not be frustrated when you're just like, I have no idea. If you feel like you're getting to that point, you should probably take a break and come back to it.
Yeah, exactly. And also the kind of confidence to not be too worried about the fact you have to Google stuff all the time. Looking up stuff is very normal. You can't put everything in your head at all times. I quite often tell an anecdote about how I've Googled in job interviews before, and if you have an interviewer who's like, what are you doing? I'm like, exactly the fucking same thing that you do every day when you're working and you can't remember a thing, possibly without the F word. That usually doesn't.
That wouldn't land you a job, I don't think, depending where you are, actually.
Well, I guess in my case, it gets people used to the idea that I swear like an Australian. But cool. So I think we've covered that off. So what do you need? It would be nice to know the sort of basic fundamentals of programming language. A programming language anyone will do. If you know some Rust, super beneficial. If you know some Linux command line, super beneficial. If you know anything about Docker, super beneficial. But fundamentally, I think what Callum said, if you know an if and a for loop, that's probably enough, and the rest will follow as long as you're kind of determined enough. And then apart from that, it's just the curiosity to keep going. So smart contract architecture. We had a few questions about this. This is kind of a more in-depth question, maybe. So to give everybody a structure this first episode, we sort of just put on Twitter, what is your most burning question about CosmWasm? So we're going to cover those questions first, and then we'll put a timestamp in for those of you just jumping in, that we're going to go through the Juno Quickstart in the second half of the hour, and we're just going to bash through getting a chain up and running and stuff. So yeah, that's the structure we're working to here. So I would say smart contract architecture is such a complicated subject that we should almost leave that for another episode.
Yeah, what I would say is that it's unopinionated. It's by its nature, it's very unopinionated. There's not really this is the correct way to do things. Everyone has slight different conventions, and you quite often just sort of stick with what you were exposed to first.
Yeah, I guess from maybe compared to other systems that I've been used to building in the past, the thing that is very interesting about smart contracts is how small they are. So even in a very succinct programming language, and then ding the bell because he's lasted 9 minutes and 12 seconds before mentioning Lisp or the Clojure programming language. Even in a very succinct programming language like Lisp or Clojure, 30,000 line code base, very common. That's probably about 10 million lines of C or something. But still, it's a big code base. I think Who Am I is about, which is the underlying contract for the name service, I think is about 2,500 lines, 3,000 lines. I think How Social is under 20K.
Yeah, I'd say around 15K.
4 contracts.
4 coming on to like 5, 6 now, but hey.
Yeah, so we're starting, and what's interesting about that is we're actually starting to break up HAL into smaller contracts again. So if you're used to making large monolithic applications, the thing that will be interesting about smart contracts, particularly CosmWasm ones, which follow an actor model, is that they're split up into much smaller chunks than you're maybe used to. If you're used to microservice architectures, if you're used to serverless, which is what I was doing the majority of my work in before crypto, these are massive. The smart contract is like, it's not 50 lines of code, it's like a whole 500, so terrifying. But if you're used to kind of traditional, I guess it is traditional at this point, but modern microservice architectures, then smart contracts will feel familiar when you're trying to build out a mental model of how to fit your pieces together, I guess.
Yeah, they benefit from being as granular and atomic as possible, like, because that lends themselves to how smart contract architecture works. Quite often, it's a lot easier to just have two contracts interact than have the one contract handle both. Like, maybe you should subscribe to sort of a very basic principle when writing a function is a function should do one thing well. That could be applied to a smart contract. And sometimes that isn't strictly possible, but just you should be able to say this smart contract does this sort of thing, and it does this well.
Yeah, that's put much better than I put it. So, yeah, and another question we got a couple of variants on this one, which was, what are the best practices for reusing code across multiple contracts? And I think this also plays into what Callum just summed up, which is that kind of know very clearly what the behavior you want to encapsulate in the program is, right? And so I guess, like, I come from a functional programming background, so I tend to think of programs as basically a set of functions, just a library that happens to have a main function that says do the stuff. I can't remember which computer scientist said it, but I have the feeling it might actually be from the SICP lectures, where there's a description of rally the troops, where you have a bunch of different behaviors you want to encapsulate in code. And at the end, once you've defined all the behavior that can happen, you say rally the troops, and it all happens. And when you're working with much smaller, like microservice style code abstractions like smart contracts, you essentially do have that, but you have a little bit of misdirection. So we'll get into this when we talk about smart contract, as in the actual internals of how smart contracts work. There are some other ones on this channel about anatomy of a smart contract, but the key point is that there's a thing called an entry point in a CosmWasm smart contract, and that is effectively the main function. It's sort of saying this is the entry to run this program, where the smart contract is just a program. And so you will see, and you will see this when we go more in depth on smart contracts in the next episode and the one after. You'll see how that behavior actually ends up being essentially an entry point to call one function, the entry point itself. And then there's simply a match statement that then matches other functions that then go and do stuff.
Yeah,
but what you'll see,
it's a bit like pattern matching with a REST endpoint, you could say.
Yeah, but so the interesting thing, the point here is that a lot of the language decisions of Rust it's an imperative language with some functional aspects. So in practice, you'll essentially find yourself in an entry point that calls one function. And then when you trace that function back, you'll find another function, which merely calls a couple of other functions. And then all of that is the behavior that's returned all the way to the user, essentially. So in a very real sense, a lot of the architecture of a smart contract is just a chain of function calls. So it is very, very familiar to functional programmers. And specifically, the question we had, the follow-up question as part of this best practices for reusable code, was asking about traits, inheritance, and that kind of stuff, because there are those features in the Rust programming language. Now, I, as one of the maintainers of CW NFTs, which leans very, very heavily on a trait-based inheritance system, I am personally more in a kind of mind that I prefer to write libraries of functions and then inherit the ones I need and not use the ones I don't. I don't necessarily think that encapsulating behavior around an object or a trait in this case is necessarily the best strategy. Is quite comforting to object-oriented programmers, I guess. But if you've maybe not come from that background, or if you're new to this entirely, then I think traits can be quite confusing, especially with Rust has a very opinionated type system, which is great for security in terms of like code quality. But it's a lot to keep in your head as a new programmer, I think. I don't know what you think about that, Callum.
Yeah, it can quite often get quite complex because you can have multiple different traits on the same sort of base sort of struct, and you can very quickly get lost in implementations of traits. I find that quite complex, but yeah, I'm completely with you on your point.
Yeah. So whoever asked that question, I don't know if you were looking for a spicy hot take. I'm not sure if don't really use traits as a spicy hot take. Maybe it's not. And then the final couple of questions here, which I think are more going to lead us into what we want to get onto in future episodes, are the first one is what are the primary components of a decentralized application?
Yep. Do you want me to take that? Yeah, I'll do it. So, of course, critical. There needs to be a chain that your smart contract is running on. Well, not all dApps have smart contracts, but we'll go. There's the chain that your dApp is targeted for, and then quite often there will be your smart contracts. So for the name service, this is the base Who Am I contract, which is uploaded on the Juno chain, and then in your front end, quite often it's common to use Next.js just because there's the tooling for that. We'll get onto that in a second. And then you then use the sort of CosmJS library, which will interact via JavaScript or TypeScript from your front end, and it will call your contract using the endpoints you define in your contract. And yeah, that's me.
I've just eaten a very, very, very sticky biscuit. So I was foolish indeed. Yeah, essentially that. I think the key thing is that the smart contracts are running in a virtual machine above the chain. So you have to know a little bit, but not much about the chain you're running on. We're going to primarily be focused on using Juno. That's kind of our home chain. But almost all of these examples that we're going to go into in this episode and future episodes will also run on WasmD, which is the reference implementation for CosmWasm, or any permissionless smart contract chain that includes CosmWasm. And it's worth saying that obviously CosmWasm itself, you can configure it however you want. So not every chain that uses CosmWasm runs permissionlessly. But if you are an app developer and you're looking to build an app chain within Cosmos, it's perfectly valid to build out a CosmWasm chain that runs permissioned smart contracts, implement your functionality as smart contracts, and then simply introduce them to your chain via a governance, which is what, for example, Stargaze do. So if you are more comfortable in Rust than Go, or you don't want to learn the Cosmos SDK, there is obviously some performance hit that you take from doing this, but it is possible to build out sophisticated applications purely in smart contracts on top of a application-specific blockchain that simply runs CosmWasm. So that's something to be worth to bear in mind. So the final question that we got before the show, I've noticed there's a couple in the chat. So if you have a question that you want to ask before we move on to me probably screwing up a load of stuff in my terminal while Callum tells me what typos I'm making, do ask them in the chat and we'll get to them before we move on. So the final question was, what developer tooling is out there to help me get started with CosmWasm?
Do you want to take this one? Okay, right. So there's quite a lot that's been coming up recently, just due to the nature of things. But you, of course, can, when you are interacting with your smart contracts, if you run a local chain, which is something we'll get onto very shortly, you can interact with it via the command line. But there is also website alternatives which allow you to just paste in a JSON and query and execute your contract as if it is just on a website. This is quite handy for debugging. That is developed by a good friend of ours at AS Weaver, and it's called CosmWasm.tools. this just allows a very simple graphical user interface to interact with contracts, and it just spits out the JSON output. And yeah, it's quite nice. What else I put? There is also a number of templates now. There is CW template on Git for spinning up a boilerplate smart contract. You will probably use it in this. And then there is also a equivalent starter kit for the front end, which is provided by Juno. I think it's literally just called starter kit under the Cosmos contracts GitHub org. And these are your sort of they're your two main components for building your front end and back end. And then there's also predefined Docker containers, which will spin up a local chain for you.
Yeah. And I know there's also, off the top of my head, there's some folks building an IDE of sorts to add some additional hooks into like CosmWasm specific snippets and stuff. I don't personally actually code with an IDE, so that wouldn't help me. But maybe for some newer programmers. And I saw on Twitter that somebody, I think they're actually in the chat.
They're in the chat. They're in the chat.
Yeah, Sporthy has put together a extension for VS Code to allow interaction with a chain. I don't know how it works because I actually haven't used VS Code in a couple of excuse me, a couple of years. But we should maybe we'll cover it in this or investigate it, because I think in future episodes we'll be doing some collaborative programming, and we'll probably end up using VS Code because it's probably
more friendly.
It's the easiest collaborative programming environment. It's quite hard to rig up Emacs to connect to a remote copy of Emacs. It is possible, but it is also, Callum, you're a Vim.
I'm a Vim man, so
yeah. So there you go. It would be a complete disaster for us to try and bridge the gap of evil mode and Emacs, as well as trying to teach CosmWasm at the same time. So we've got a few more questions in the chat. Usurper has asked, when is the How to Rug episode? I think you have us mistaken for another podcast, sir. We have, question.
This is a good question.
Yep. So from Sporthy, do we need to pay much attention to logic optimization when writing contracts? How relevant is it to worry about space and time complexity of the contract code? The answer is everything becomes a map, because maps are quite efficient and your users are paying gas. So on other environments, particularly Ethereum, it's obviously very, very common to actually essentially be talking to an indexer and doing very little of it actually interacting with the chain. I mean, to be fair, even putting metadata on chain on Ethereum is too expensive. Whereas, for example, name service is NFTs, but all the metadata is on chain. Other projects that we're working on, that we should be working on together, like How, also store a lot of their data on chain, and that's quite new to Cosmos, but it does have the side effect that you do need to be concerned about optimizations. And I think particularly for some of the work that you've done with DAO, as well as actually some of the staking stuff for How, you've had to worry quite a bit about optimizing, haven't you?
Yeah. So quite often, just sort of for time complexity instead, there is quite I think it's written somewhere in the docs, is that if you can avoid, the traditional for each loops in Rust, if you can, sometimes you can't, that is unavoidable. But if you can try and use the fold, like do you use the Rust iter system? I don't know what the actual proper name is for it, but perform folds maps, because they're interpreted lazy, aren't they? They only run when you call collect on it, and it does all the work at once. But that allows, I think it's the VM, to determine the sort of gas usage a lot easier than just a for each loop, which probably can't be determined as easy. But quite often, it's very rare that you'll hit the limits. We've probably had conversations about how with this, but it's quite polite, because I remember on the Stargaze, for their add to a whitelist call, because I've done a couple mints on Stargaze, you can actually do like 500 addresses at once and not hit the gas limit. So it's quite lenient, the gas limit, and it is configured per chain as well. So that's definitely something you should be aware of.
Yeah. So just touching on that, the gas limit Callum's talking about is that there is a block gas limit. So not only do you have to worry about gas in terms of charging your users too much, but you can also burn through so much gas that the block actually won't be valid. It would be quite hard to do that with a single smart contract. The main reason you would do that would actually be an attack, and it is possible to take down a chain by doing that. Before Juno launched, Ben2X4, who's one of the developers behind Juno Swap, and I took down Juno's testnet by doing a smart contract attack like that without telling anybody we were going to do it ahead of time, and it was quite good fun. So that's, if you do something that's very badly optimized, you're probably not going to take down a chain, but you are going to take down that smile on your user's face as they see the gas cost of what they've just done. But yeah, actually, and this is another interesting point about Rust that Callum has. I nearly just called you Cosm Callum.
Don't ever call me that, please.
That Callum has touched on, which is that the iterator, and this is kind of getting into Rust internals, and we're not going to probably re-encounter this again for some episodes. But if you're familiar with Haskell, Clojure, modern functional idioms, even in potentially even in things like Python, you might be familiar with iterators as a concept, which are essentially a map and reduce function where it reduces. The best way of thinking about it is map is I have a list of things 1, 2, 3, 4, and I say add 1 to all of these things. That's a map over them and an application of a function to all of them. In this case, add 1, and I end up with 2, 3, 4, 5, 6. And then a reduce, which is to say, I would like to reduce all of these down to one thing. Now, intuitively, you can work out from that if I had 2 maps, my first map function adds 1, my second map function reduces by 1, that I don't actually need to apply those functions yet. I can just wait until the end and work out what they all are in one go, because all of those, actually, even if the array length, if the collection, the 1, 2, 3, 4, 5 set of stuff is changing, it's only a single application for each bucket, essentially, until the length gets changed, which is another story, linked list, blah, blah, blah. But then as soon as you do a reduce, the collect that Callum was talking about, where you reduce things down to either a single scalar item, i.e. a single number. In this case, where we've got 1, 2, 3, 4, 5, 6, 7, when you say sum all these numbers, like add them all together, that's a really good example of a collect type action. It's actually a right fold reduce, I think, a sum, but you can think of it as just, yeah, add these numbers together. That means they all do actually have to be computed. So what compilers can do, what the system that's interpreting the code that you've written can do, is to remove all of those individual collections that would be computed and just say, oh, just do the last one when they all get realized into a real thing. And this is a technique under the hood in programming languages like Clojure, Haskell, and stuff like that. And it's also an optimization for massive big data pipelines and things like Apache Spark, that run recommendation engines for Netflix and stuff like that. The main takeaway from that is it's just very, very performant, and that's why it's important. And that's why it's like, oh, right, the iterator under the hood is from that same school of computer science optimization, right? Which allows you to do those things in a very efficient manner.
Yeah,
I really like MapReduce, which is why I like talking about it. But I should shut up now, and we should move on.
Most toy projects, you won't have to concern with that because you won't be performing so many iterations, or you won't be using so much like space, like storage. But so most toy projects will be fine. But also with just the nature of these chains is that they're quite polite now. Like they're quite performant, and you can get a lot on chain in Juno and sort of any Cosmos chain nowadays, really, if it's configured right.
So Finn McCosmo has said, will this be for coding existing CosmWasm chains like Juno at dApp level or building those chains themselves? This is going to be for building dApps with CosmWasm. Building a CosmWasm chain is out of the scope of, just to be honest, because if you if you know how to build a CosmWasm chain, you already know how to build it. It's kind of a tautology, but the number of developers that can do that is relatively small. And if you need an implementation of a CosmWasm chain to play around with, Juno or WasmD are out there, and I'd recommend just digging around in the source code. That's probably the best way to understand how those work. If you need to write custom, well, so there's another thing here is that obviously you can interact with Cosmos logic, SDK logic at chain level from CosmWasm contracts. So there is still a reason you would want to maybe implement some stuff at chain level in Go. But in most cases, just because it's really hard for developers to switch contexts, you'll find that people go all in on CosmWasm or they go all in on chain code. So actually, building a CosmWasm chain is not that meaningful, given that CosmWasm is just a module you include in a chain and then you're done. That's it. You move on. So yeah, I mean, you can literally just fork WasmD and then configure it if you want. There you go. That's the episode on that. Just fork WasmD and configure it yourself. There's quite a lot.
It's that easy, guys. Come on.
It's that easy. So bonus episode idea from Usurper of going through Callum's Vim setup. No. And final question, another one from Sporty. Our validator is going to be okay if I want to put 10 gigabyte of metadata for an NFT.
This is what we're doing with How.
A little bit, yeah. So obviously not on one NFT, but yeah, metadata, on-chain metadata does cause a big storage growth. Does chain limit storage usage? Not really. It's all kind of tied into what is paid for with gas. There is an interesting and complex question, I think, about what happens when inflation stops and whether it's still economical to deal with the storage growth that incurs at that point. There's also probably a question about what is appropriate to put on chain and what isn't appropriate to put on chain. And so far, a lot of stuff has been pushed off to IPFS. And I think like there's probably more stuff should be on chain even now than currently is. But addressable storage is also a problem in terms of getting it from smart contracts, which I think we will have different thoughts on how to solve that particular problem. Okay, so I think that is all of the questions we had to get
pretty on time, half and half.
The goal was to do half and half. Maybe we should have done it back to front and just tried to. The problem is the live demo is high.
People will get more questions as well with the live demo.
They're always high stakes, and I think I was just concerned about the fact that it's almost certainly going to blow up my laptop or go wrong, because these things always do. But right, so what we're going to do? Actually, I'm just going to double check that I have the current tip of Juno. I might not. I didn't. Okay, cool. There we go. So I've got Juno up on my laptop. We're at the tip of the main branch, and we're just going to launch the chain in development mode, and it's hopefully going to work. So
oh god,
it's going to take a little while, because we'll show you there's several ways you can run in Docker. We build, Juno builds and publishes targeted releases that you don't have to build yourself. You can just pull them down every time we coin a release. So there's loads and loads and loads of versions and point versions that you can use if you want to target a specific version of Juno. Generally speaking, you want to just like look at whatever the current most recent is. As of the time of this video, it's version 6 of Juno. And version 7 is in alpha testing at the moment. So we're going to show you first how to run Juno in using Docker Compose, which is a tool where it builds a container, a little local container for you, and then runs that. And there are some downsides from doing it this way. Mainly that it takes longer because it does it without a build cache. It just does it from scratch. So generally speaking, you only need to do what we're about to do now if you're actually working directly on a current version of Juno that has to be exactly with whatever current changes you made to it, which is very uncommon if you're not a dev on Juno. I think the last time even I had to do this was while diagnosing a problem with the pseudo contracts that we then had to submit a patch upstream to WasmD. So but the reason for doing this as a new dev is because it's so easy. It's one command. And without further ado, that command in the docs is this. And we'll go through that in a second. I'm just going to also drop in the chat docs.junochain.io, I think is the doc site. Is it Juno Network?
I'll verify.
Oh, it might be.
Oh yeah, there it's docs.junonetwork.io.
There we go. I think it might have been Juno Chain before we launched.
Yeah, it's been changed with
I think it does actually still work. It just redirects.
Okay.
So what's going on here is there's a couple of bits of configuration. The stake token of Juno is Juno, but we've called it UJunoX just so that we don't accidentally get confused and spend our real Juno when we're mucking around in development later. So it's just because we're going to actually, we'll show you how to connect to this with Kepler. You're going to really want to be 100% clear at any given time which chain you're working with in Kepler. Unsafe cores is another configuration option that we have in Juno. That's going to make it easier for us to connect to it from a front-end application. They're all running on our local host, i.e. in this case on my laptop, but they'll be running on different ports. So if you don't set some cores configuration, which stands for cross-origin resource sharing, doesn't really matter what it is from the point of view of new developers, you can Google it. But what it will mean is if two things are running on two different ports, they might not be able to communicate with each other on your laptop. So we set that so that the chain that we're about to launch knows that it can accept requests from anywhere, in this case, just from another place on the laptop, but it could be anywhere. And then the real meat and bones of this is the Docker Compose up command, which is any project you can run with Docker Compose is just Docker Compose up. The arguments in front of it are just environment flags. So, I mean, just to be really clear, environment args in a Linux command line, if you're like, yes, and then echo, yes, there you go. It's very Peter Hanrahan that, but so that's why we have those two sets of arguments at the start and why they're capitalized, because we're saying these are arguments we want to set just for this command afterwards. Although I guess they will be set, they will persist for a little bit. And now, you know what, I should have set this off running and then talked about it, because now it's going to do a load of stuff. And so there's some interesting stuff it's doing here. Is that right? Yeah, no, that's right. That's right. It's good. For a second, I had a little, was like, okay. So this has, I think, it looks like it has successfully decided that I am on x86. Good. Be a bit embarrassing if it crashed at that point, because I'm pretty sure I'm the maintainer of the Docker file.
Schultzy raises a good point that Docker-Compose is being deprecated in favor of Docker Compose. So if you're on the latest version, just heads up about that.
There you go. So yeah, Docker space Compose. And Schultzy, since you said it, do you want to add a commit to the Juno docs with, you can add a little info tip if you want to do that. That would be helpful. Pull requests gladly accepted. And then, yeah, what it's doing now is by far the longest step, which is it's actually building the Juno binary inside the Docker container. So we could have done this, and maybe I'll show that actually after this, just how you can build Juno if you want to run it on your host, but it's just more can go wrong. You have to worry about the configuration and editing the configuration files yourself to get it running. So it takes more time basically to do it that way than to just run the Docker container. But if you're a node operator, if you're a validator, you get very, 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 very familiar with running make build and make install for every single Cosmos chain that you are building binaries and shipping binaries for. Oh, I had a couple of questions. What's the repo for the GitHub Actions examples? Okay, so that's just the Juno repo has a bunch of CI that does various things. Yeah, it's just github.com/cosmos contract/Juno. I'll put it in the chat. Yeah, we actually test quite a lot of stuff with Juno at any given time. So on pull requests, we run a bunch of tests against the smart contract to check you can instantiate it, to check it can do some basic behavior. I think we check that migrations work, and we definitely check that the Unity contract, which was the Prop 20 contract, we actually instantiate that and I think submit a gov proposal against that contract in a Docker container to check that it succeeds, because we found a regression involving that when we were originally testing it, and so that there is a piece of CI on GitHub that checks that is actually functioning and is not regressed, because obviously, well, okay, bear market, I think that contract at one point was governing what, $120 million.
120 mil, yeah. I think
now
it's definitely not that. I think it's below 10.
10. So
5,
yeah,
6.
okay, not as much as it was, but at the time, a lot of money. So there's some continuous integration steps that kind of govern that behavior. And this is kind of why I mentioned this doing this via Docker Compose does take a while. We're up to 200 seconds, and I'm at the point of having to get up Spotify and play some tunes. Oh, there we go.
There we go. Perfect. The threat of listening to your music made it run.
If it crashed at that point, I would be so pissed off.
Oh god.
And there we go. We've got blockchain, I think.
Yeah. I haven't done this in ages. I
remember doing this. We've got blocks. Yeah. Blocks.
There we go. We just launched a chain, guys.
We just launched a chain. There you go. Cosm Callum chain is live.
Another question from Daniel. Not sure if I missed it, but what's the CW template do you recommend using when getting started? The official one from CosmWasm. It's not under CosmWasm. It's under InterWasm. It's just CW-template on GitHub. Search it up. It'll be there. They have good version tags, and it comes with some basic workflows to sanity check your contract. So when you push it to Git, it will run the tests against it. I think it now even checks for schema changes, and runs like all the linting stuff for it. CW template. I'm not logged in on YouTube on this, so I can't paste a link. So I'm pointing to my handsome assistant to do this.
So there you go. There's the template. You can also pass some additional arguments so that you get a minimal template, or you can, if you pass it with, I think it's no arguments. It gives you like
It gives you the head, the main.
The bean counter. I call it the bean counter, but it's whatever it is. It's just a counter.
The one that took down Juno, by the way.
Baby's first rug pull. But yes. So if you need to see like a super simple example smart contract, that's a really good place to start. And actually, we will be starting with that. That is literally what we'll be doing in the next episode. Is kind of do the anatomy of a smart contract, using that as an example. And then I believe we also have Callum's CW tier list, which I thought we were going to write on this podcast, but Callum got overexcited.
No, I had to.
Time.
Yeah, but we can use it as a reference, and I'm going to use it for a later course as well. I wouldn't write it live because there were actually some things where I was like, oh wait, this actually requires some thought. But yeah, we can do CW tier list. We can give the people what they want.
CosmWasm by Dummies #2 template overview. Pretty much.
Probably
Yeah.
will be, yeah. Actually, it will be.
So Finn's asked, is this a node on the main Juno blockchain or a local version of Juno running only on the machine? This is local only. And this is actually one of the great strengths of the Cosmos ecosystem, is the ability to run a local development environment, just like you would run a Rails server, just like you'd run, like a Python web server or something like that. And we obviously have done some wrangling to make this possible. Like we had to add some additional stuff into Juno to make it work, but you can, again, basically clone WASMD and add some additional configuration, and you can run a node on your machine. So Starport, which is the Ignite dev scaffold, also has its own way of running a Starport local server. We at the time that this was done, I'm pretty sure that maybe it was like me and Jacob from Notional pretty much, and I think maybe Jan's Alex working on any of this stuff at all. I think there was literally just whoever gets there first with their solution wins, and I think we're all vaguely Docker people, so it was like, okay, well, we'll just throw it in a Docker container, job done. Even though Juno is actually a Starport project, it's just, if you're used to running stuff in Docker, you're just like, right, I just want to run the chain in Docker and not run it on my host. So that's why Juno is run via Docker. But yeah, it's just used for testing and building. It's just local. And we've got, is there a testnet where people can join contracts as well? Yes, there is. Juno has a testnet called Uni3, but we're going to actually deploy some stuff against this one. So we've deployed a local blockchain. This is now running. It has some ports open. So we can show this using our magical. So this actually has a command open in it, which is to create a Next app that can interact with the thing we just launched, the blockchain, right? So I'll put this in the chat.
Yeah, this was the starter kit I mentioned earlier for bootstrapping a front end.
Bear in mind that this will also actually obviously create a project named CosmWasm for Dummies. You probably want to change that. So I'm gonna set it creating that so you can see what it looks like. And in true Blue Peter fashion, I've actually, here's one I made earlier. I can do that in a second, but there we go. So that's done. But what I actually also wanted to show was that if you do, I've already created, I already have Juno on this machine, obviously, because it's a dev machine. But if you want to interact with the chain you've just created, because Juno automatically looks for the default port to query the chain, you can actually build Juno on your host and then communicate with the one in the Docker container, because the Docker container is exposing the correct ports so that it knows where to find it. So I already have Juno, so I can do Juno D status, and it says that I have a node info with voting power 250. So although there is actually no Juno currently running on my host, it's running over there in the Docker container, because the Docker container is exposing the ports that would be mapped if it was running on my host. You can actually interact with it anyway. But I can do this because I already have Juno installed. So I'll very quickly show you how you would do that, which I have to remember the path to my Juno directory, which I think is that. Yep. Okay. So, and then, you would do like, to get Juno, you do git clone, what is it?
github.com/cosmos/contract/Juno.
Juno, which I'm not going to run because I've already done it and I'm in Juno, and that would just really ruin my day. So, but you do that. Then when you've got it, you're at the tip of the main branch, and then you just do make build and then make install. I'm not going to add the make install bit because I don't want to replace my current Juno binary with the new one. But if you make build, it should build. It'd be really embarrassing again if it didn't. But yeah, if you do make build and make install, it will then install Juno onto your host, and then you can muck around with it locally. If you do just make build, it'll stick it in bin, I think. That's it, version. Yeah. So what that's telling you is, so the current, I mentioned the current tag is version 7.0.0 alpha 2, and then the extra information after it is just a hash saying that it's not quite that tag, it's actually ahead of that tag. Hence why, whereas if I did Juno D version, actually I have literally no idea what version is running on this machine. There you go. So the version that's installed on this machine in my user's bin path is version 6. But, you know, if I wanted to test just what happens when, yeah, okay, so bin Juno D status, does Juno D status work on the current Juno binary that I'm working on in development mode? I can do that. Yeah, it works, doesn't blow up. So that's the reason why you might want to build a version without installing it into your user's path, but it's quite unlikely, I guess. So let's CWFD, I think. Oh yeah, of course, because we're miles down in this folder structure, aren't we? Okay. So we now have this folder called CosmWasm for Dummies. So CD CosmWasm for Dummies. And I've just remembered why this is a bit of, so actually hang on, let's have a look what's in this folder, what's it given us. We need to, from memory, move some configuration, don't we? Yeah, so where is env.example?
It's not, it's hidden because it's prefixed with a dot, so you need an ls-al.
You are correct, sir. Doxed, I'm the fray. Sorry, it's just not even funny. So cp.env.example, and I think it needs to be called env.local.
Yep. So you can have different .envs and they have certain priorities. Just even when I'm running on a test net, I just name it .env.local because I know that one works. But it will try and find one, and in this case, it will find .env.local first.
Yeah, so what we're doing here is just adding some basic configuration so that this application can find that Juno chain that we've just run. And okay, that I think worked.
Yeah, it should be pretty plug and play, if I remember right.
I'm just trying to, yeah, because it's been a little while since I've done this, so I'm just trying to remember what will need changing. So okay, so then this is the next interesting thing, which is that there's a set of basic configuration here, and we'll go through why this matters. So the icon URL is just an icon for the app, so we don't have to worry about it too much. We'll change the site title to, yeah, maybe if we actually needed a website, we could use the.
Yeah, we can launch a new website right now.
Launch a new website right now. So this gas price is, oh yeah, what is it? Oh, right, yeah, I've just remembered what the starter kit does. It allows you to send transactions. So it's configuring a default gas price. It's asking what the coin decimals are, because they might be different. Juno is 6. It's asking what the public staking denomination is. Now, you remember we set that when we launched the chain to be UJunoX. So if that was different, you would just change it here. And because these are environment variables, when you deploy this application, you can change it in your production configuration. No big deal. The REST endpoint, this is very important if you're coming from Terra, because Terra people bloody love the REST endpoint for some reason. So REST is an API standard for defining web services or HTTP services. And it basically just means that you have a kind of known standard API: get, post, put, patch, option, delete.
There's loads more, but they're the main ones.
There's a few more, but nobody really cares about those. So the main thing is that, like, to get information, to query information, it's get. They map onto the HTTP verbs, right? So creating stuff, creating resources tends to be post, patch and update to update information, blah, 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 blah. People really like REST. So if you're very, very familiar as a web developer with REST, then you're going to be interacting with localhost 1317. The only thing to be wary of is that the REST endpoint, a lot of its functionality has been deprecated as of more recent versions of the SDK. So the big one I'm thinking of is the transactions endpoint, which used to exist and doesn't exist anymore. So generally speaking, functionality is going out of the REST API and into the RPC API, which brings us onto the RPC, and we'll talk about that in a second. The REST endpoint also has, quite usefully, a really good set of documentation, which, if I'd been thinking ahead, I would have got up ahead of time, which I have maybe got. Oh, that's the RPC. That's also useful.
It just has the sort. It has like I think it's Swagger. It literally, if you go to that endpoint, it has the Swagger docs for each endpoint that's enabled.
Yeah, I'm just trying to see, because there's a live one for Cosmos, isn't there, which is super easy to use. All right, here you go. Oh, no, that's the legacy one. That's annoying.
I've got the Uni Deus Labs one. If you, which is lcd.uni.juno.deslabs.phi.
Do you want to post it in the private
Yeah,
chat?
yeah. Let me actually. Oh wait, yeah.
As you can tell, we're super. This is our first episode. We are super organized. But I do think just before the hour expires, we will actually get this out.
We'll have a website.
We'll have a website running on Juno, and you won't have seen any CosmWasm happen. But that's episode 2. Okay, there you go. So LTD Uni Juno Deslabs.phi. That will show you what's available via REST on Uni
for the Juno testnet.
For the Juno testnet, exactly. So, and then above that we have RPC. RPC is a different way of doing HTTP requests and calls that allows for more arbitrary types of call to be made. Why is RPC going to be particularly important for us, Callum?
Because that's how that's how we do that's how I do everything. That's just how we make transactions.
And how and why is that?
You've really caught me off guard here. I'm not gonna lie. It's just how I've learned how to do it.
So the reason RPC is super important is it allows more arbitrary structures of data to be sent than maybe a traditional REST API, which has like its own kind of boxed nature of like, this needs to be this structure, this needs to be this structure. RPC is a bit more freeform. And in the case of CosmWasm smart contracts, we want to basically define our own behavior, right? And just kind of within our smart contract, we say what is a reasonable request, what is an unreasonable request in terms of data that can be sent to the chain, right, where our contract lives. And so RPC is maybe a more natural fit on the whole for that. So most of the time you'll see people interacting with smart contracts via RPC, and smart contracts expose their functionality as JSON schema checked data via an RPC endpoint as well. Oh gosh, we've got some Confio people in the chat. That's quite.
I just realized I've come in. Frey asked me a question. I started squirming as Confio.
Oh, we've got Misang as well. Hello.
Yeah, we've got
Misang and Bart. So anyway, the reason this is important, is that RPC endpoint, very common. You're going to be using that a lot. REST endpoint, you're going to be using it a little bit less probably on the whole. Their standard ports are 1317 for the REST endpoint, and RPC endpoint is normally exposed unless you configure it differently at 26657. And if you look in the configuration file for the compose instruction that we just ran on GitHub, on Juno's GitHub, you'll see that when the container launches, it exposes 26657, 1317, and 26656 to the host, which is why we can talk to it. Final things in this configuration file that are useful. Bec32 prefix, every chain has one. It's just, so everything after the 1 in a wallet address is the actual address, and the Bec32 prefix is the bit that denotes what chain you're talking to. So this bit could be, it's Othmo, right?
Yeah.
Or
Edmos, stars.
Yeah, exactly. So this, I guess this would actually work with any, this starter kit would probably work with any chain that's on the same version of the SDK. So you could actually change it. And then these two bits of configuration are for Kepler very specifically. So Kepler has a feature called Suggest Chain that allows you to say to it, I am running a local blockchain and I would like to be added, essentially. And yeah, you need to just say what you want it to be added as. So you want this to be like Juno local test, no, seriously, not live, it's okay.
You can use the seed
lads.
wallet.
So that when you look down in your Kepler, you're like, oh, that's the one I want, like straight away. I think on mine it's called, I think it's actually literally just called this on mine.
I think mine's just called Juno local test, and I just make sure every time.
And then the final thing here is like, what is the name of the chain that you want to connect to? When we configure that Docker container, the configuration value by default is testing. The chain is called testing, which is a bit of a weird name. So most chains have, if you look at like mainnets or even test nets, like Uni for Juno is called Uni 3 currently. Juno's mainnet is called Juno 1. Other chains do things where they increment, especially for legacy upgrades, they've actually incremented fully. So I think Terra before it crashed was on Columbus 5.
Yeah, I think the hub has also done something similar because of older versions.
Yeah, so older versions of the Cosmos SDK needed to do upgrades in a different way. So they actually stopped and started a whole new chain in a lot of cases. So anyway, that's the configuration. That's what's important. And now I think that should.
You didn't actually change any. Oh no, you changed the title. You changed the title. So yeah.
Did I change the title?
No, just save. It just said it should all work.
Okay. So and then finally, we should be able to do yarn dev and it will just work magically.
You need to install. Oh wait, no mind. It does.
I need to install.
We'll find out. But never mind.
Here we go. What am I doing? all live demos eventually devolve into
us yelling at each other.
I need to show a web browser, don't I? Right. Okay. Let me go find it. This is still very in flux, as you can see. Oh, and actually, yeah, I should post. Did I post the Tendermint RPC information? I should post that. So I'll just put in the chat as well. The Tendermint RPC link, which is basically means you can look up what the different options are for you via RPC, and then there's obviously a separate one for WASM stuff. When we get on to front ends in about 10,000 years, in a few episodes, we'll be talking about CosmJS, which actually gives you a quite user-friendly way of just querying an RPC without you really having to worry about constructing the request to be the perfect shape. It sort of knows what the shape should be and does it behind the scenes.
It has some cookie cutter stuff that you're probably going to want to do this. But if you wanted to interact with a chain via an RPC through Python, then you'd have to go through this and serialize the request yourself.
Yeah. So I'm going to attempt to move my oh, no, that didn't work. Okay, there we go. And then CosmWasm by Dummies. There we go. So this is what you get when you run the starter app. I actually am not logged in to my Kepler on this machine at the moment, so I can't show you the magic of pressing Connect Wallet. But what will happen when you hit Connect Wallet up here is that it will throw open a dialog box and it will say Kepler wants to suggest a chain. It'll say, do you want to add whatever it was, testing local test smiley face to Kepler? And then once you've done that, you'll be able to go to this page. Oh, there you go. Okay, well, there you go. Localhost 3000 would like to add blockchain testing to Kepler.
Yeah. You're probably quite familiar with this dialog if you connect a lot of chains via osmosis, because it has to request to make the transactions on that chain.
I was kind of wondering when it would.
Familiar for.
I was kind of wondering when it would stop working because I'm not logged in, and the answer is at exactly that point. It just errors and just loads forever.
Yeah.
But if you and it's actually just going to keep erroring now. Oops. So if I was actually logged into my Kepler, first of all, it would dox my Kepler, which would be great to do on a stream. And second of all, you'll be able to see a screen here to actually send some funds. And then we'd be able to do something magic where you could send funds and you'd be able to see it happen in the block, which is pretty cool. But I'll leave that as an exercise to all of you to do. But so the key thing here is, although it doesn't look like we've done a lot, we've run a local blockchain, we've connected a front end to it, and then that front end has actually added the chain to Kepler. So once you've done that, you can then expose all sorts of fun behavior. I mean, you can actually just build whatever you want, really. But there's very importantly, if you go to the Juno docs, and I've got them up here, there is not only pre-built Docker containers that we mentioned before, but there's also this user that is essentially, when that command runs to run the chain, it bootstraps a user for you to use and gives them a bunch of funds. Now, obviously, don't ever use this as your mnemonic on mainnet because everybody in the world knows it. But just for the purposes of running a local development environment, it's a good idea to add that user, and then you can add them to Kepler as well. What does the console show? Why is it not? It's not so Daniel has asked, why is it not loading? The reason it's not loading is because I'm not logged into Kepler. So Kepler throws an internal error.
Yeah, it tried to suggest a chain when Kepler isn't set up, and it just hangs.
And if I planned way ahead, I would have already loaded Kepler and put in a fake wallet, and then I could actually open my Kepler without doxing.
Yes, millions. The company, he's just very rich.
I am Takumi. I am the whale. That's why I don't want to show.
Don't go out and say this on one end tonight. We should just cut the stream. Cut the stream. Cut the stream.
Clip 4 seconds of the stream. I am the whale. But yeah, no. So this will just work if you're logged into Kepler. Hang on, mate, hang on. Let me just see if I have another window open that is logged into Kepler that isn't like massively doxed.
Usurper suggested a good thing for next episode. We can use a new profile. We are Takumi.
Who's this Takumi guy? Let me see if I have any other windows that may or may not be logged in. You see, this is very excellent. Very excellent planning here primarily on my part. Okay, no, tell a lie.
Are you already on the local one?
I actually have. Can you see that?
Yeah, there we go. That's good.
So,
that's good.
So that's a local. I think.
But you are on your company account, just to let you be aware.
Yeah, it's kind of. I think it's probably fine. So
there we go. Yeah, that's what you should. That is what you'd expect to see. And if you go to send a wallet, it just allows you to send Juno X. But of course, this wallet doesn't have any because it's not the seed user. The seed user spawns with. Is it 1,000? Because the micro denoms, you define it. It spawns with enough test Juno for you to then test.
Yeah, I think it's about 1,000. It's something like that. And I should actually have the unsafe test user. Let me just see.
When you import that seed, by the way, definitely name it something in all caps, unsafe dev user or something.
You can see here, like unsafe test user. And it's got the same. It's very, very, very small. I'm sorry about that. Like you can't make Kepler bigger, but that's the. Believe me, that is definitely the same address that is in the documentation. So, anyways, it's there. Okay, it's ever so slightly bigger there. But yeah, and then you can see center wallet, and you could, if you wanted to send to another testnet wallet that you're mucking around with in your local machine, you could do that. So yeah, that proves that I wasn't lying, and this is a running blockchain. There definitely is a blockchain under there. So the other thing to bear in mind is that you can run, and this is the final thing we'll show from this episode, and then we'll do a couple more questions, and then we'll wrap up at that point. Next episode, we'll do deploying our first smart contract, where we're basically going to do pretty much all these steps, except we're not going to explain any of them because you're all local development blockchain experts already, and we'll just start throwing contracts at it and going like YOLO.
And we'll start counting via a contract and taking down the chain.
I'm just going to count some stuff. It's no big deal. So what I'm going to do now is run. Did I still have the thing up? Yeah, I did have the thing up. Okay, so this is a blockchain. It's running. Believe me, blockchain. You can see it running this way. Whatever. We're now going to kill it and run a node using the incantation in the docs, which hopefully is going to work. And it's a bit out of date. Another thing he's noticed from the docs that are out of date.
So 6.0 is what we've currently got on mainnet as well, right?
Is it, or is it 6.0.1?
It's 6.
It's one of those, and I definitely should know that because I'm the primary maintainer. Let's have a look. And then I will update the docs later. It is 6.0.0 apparently, so happy days. I did think it was 6.0.1, but maybe I'm wrong. Well, I'm obviously wrong. Okay, cool. So let's very, very quickly go through what we're looking at here. So this is, we're going to run, do we want to run it interactively? That might be wrong. We'll have to see. We're going to run it with the same node as Docker Compose would use. That just means that it's expected, it doesn't break our expectations, basically. And actually, yeah. And then this is what I was talking about exposing ports, right? So we're exposing 1317, 26.656, which is the consensus port. We don't actually, I guess, need to expose that technically, but it just means that we could talk to it if we wanted to. We're again going to set the state token to be Juno X or Junox, as I like to pronounce it. And then we're setting unsafe cores. Now, if you don't set the unsafe cores, that next app we just launched can't talk to it. So that's why when I was talking about cross-origin resource sharing, that's why we need to configure that. And then this is just the name of the container on the next line, which looks super complicated. It's just because GitHub, what's it called, archive repository thing has that annoying additional bit at the front. And then we're just saying set up and run the Juno container with that same test user that we already showed you. And this should be quicker than doing it the other way.
Start the clock.
There you go.
There we go.
So, and there we go, first block. So time to first block was what, 300 seconds, I suppose, doing it with Docker Compose. Doing it from the pre-built image was probably under 10. That is probably, though, because I would imagine that version 6 of Juno was already on my machine. So if you have to download it, add maybe another 10 seconds to that. So yeah, and again, just to show you that it's definitely working, let's open up another window and do community status. Definitely a node in, oh yeah, it's tiny, isn't it? Sorry about that. Yeah, you can see that there is definitely a blockchain there. And for the final trick, I'll just again show you that why did I close that window earlier? That was kind of foolish. Let me just literally reset.
Professional setup.
It will be smoother next time, guys. I'm sorry. Let's get okay. So yeah, and then CosmWasm Dummies, and then there you go. It's should be still working.
And there you go.
And then what we'll do is I actually have another. So on the project that Callum and I primarily work on these days, we have about 17,000 different wallets. This one I've just switched to as one of them. And I will send it some tokens to show you that this is working. Because I promise you, this definitely does work. There we go. Okay, so we're back to this one. As we I showed before, we've got 1,000 Junox. So let's spread the wealth. Let's do some 500s. Look at that. That is generous.
And then it should pop up with the Kepler transaction. You should all be familiar with this.
Yeah. So spread the wealth. Wait, hang a second. I am spread in wealth. And then these numbers are kind of configured when you add the chain from the Kepler configuration. And then, so yeah, we'll just approve that. Hopefully that's enough.
Oh, there we go. It was a success.
So now, via the power of magic and the blockchain, we should be able to see that this amount has come out. There you go. So a little bit for gas plus whatever was left there. And then if I switch to the other one, which I think was the dev user 2.
Yeah, I think so. Yeah, there you go. It's got 500 now. You can see it on
It's got 500 Junox. There you go. So 500 Junox, definitely 500 Junox. Definitely wasn't lying to you. And there you go. That's, and if we scrolled up here, you'd see so you see number of transactions in the block, and you'd actually see in the block that it had one transaction, which would be the send, which is non-valid TXs 0, 0. So this is quite foolish. It's possible I won't be able to spot it. Just trying to visually parse a blockchain is a new trick that I've not tested very much. Oh,
there it is. There it is. Scroll down. You just missed it towards the bottom.
Oh, there you go.
Number TX is 1. There you go. I'm surprised I saw that.
Number of valid TXs. There you go. Eagle-eyed Callum. Add another skill to his quiver. He manages to visually parse a blockchain. So there you go. Proof. One valid transaction. This is a local blockchain. It's definitely working. This hasn't been an elaborate rug pull for purposes that elude
That comes next episode.
That comes next episode. There's going to be a very elaborate rug pull. Okay, so let's wrap up there. What have we done? We've run a blockchain on your machine. We've showed you how to add it to Kepler. We've showed you how to interact with it. Well, you can actually interact with it directly from Kepler. We've also shown you how to interact with it from a web app. That app we installed, the Juno starter kit, you can extend to do whatever you want. A lot of applications that have been built on Juno have been sort of based on that initial setup. And you'll be able to see in there, there's some configuration for Kepler and a variety of other stuff that you can then move around, like the gas fees and all that sort of stuff. It's all configured in the suggest chain part. So if you have any questions on that, like specifically, drop them at us on Twitter or on YouTube, and we'll add some additional information to the videos in future. Like we'll come back around to it or something like that. I was about to say, if anybody else has any questions, ask them very quickly, and we'll do them before we go. Otherwise, just noticed we've got one from Finn again. I'm just trying to find my cursor, doing the thing you do on Mac where you shake your cursor and it bursts up. Okay, so Finn says, when you shut down your chain, does the state save so next time you run it, transactions you made will be there? No. Except yes. Well, no, but also yeah. So you can attach a data volume. You can attach a data volume to the container run, and then it will persist when you shut it down. So the answer is you can do it. The default configuration is that it blows it away, so that your state always starts from block 1. So you'll see that both these times we've run it. In the Juno docs, there's actually a link to, I think it's either the DAO bootstrap script or the Who Am I bootstrap script. Both of those project bootstrap scripts, I think, do save their state. So by default, but they also, curiously, if I remember correctly, both of those projects, which I've done some work for, also blow away the data container when they start. So the answer is you can do it. Most people will start from scratch every time they initialize a blockchain on their laptop.
Yeah. How we do it, we just always go from scratch and perform any setups in a bash script to get it in the state that we want.
Yeah, exactly. I think the repeatability of starting from a completely fresh slate each time, and that's also being essentially what you would do in continuous integration, means that for me, I don't mind going and making a cup of tea while I wait for it to launch. But if you wanted to make it persistent, you could do, and as Daniel has said in the chat, if you want persistence, you can use a testnet as well. So, for us, for most projects, I guess, that are running live smart contract projects, they'll have a version that's live on the testnet constantly, and they'll also have a mainnet version. So something like the name service, which is currently live on Juno's mainnet, has testnet dens.vercel.app or whatever it's called, is the persistent testnet state, and that does change occasionally. It does get reset, but mostly it's the same state. So what Daniel said, run it on a testnet. Especially if you want real users to interact with it, that's kind of the main reason that you want persistence, because your average user is going to be like, where's my stuff? And also you couldn't exactly just tunnel them to your laptop anyway. So I don't know what I'm talking about. It's time for me to go get another cup of tea and a biscuit.
Yeah. And the only thing that needs to change when running it on a testnet would be that .env.local file. You need to point it at the testnet, not your local. So you'd have to find a testnet RPC and an LCD, but that's all available. In Juno, in the Dev Lounge channel, there's a bunch of pinned testnet and mainnet RPCs that you can use. And it's quite easy to move from local to a testnet. We've done it a few times now, and it's pretty seamless. You just got to have a little bit of patience. As with anything.
I was going to say, it's interesting because actually that has reminded me that you do that and actually run against the testnet from time to time, whereas I almost never do that. But it is actually very easy to do, as you point out. I'm just a very lazy bastard, basically.
There we go. That's what we learned. We're all lazy, but
I think that's
we
what
write code occasionally.
Amazing. All right. Well, thanks very much, everybody, for joining us. Hopefully this was useful. If you have comments on the format, please let us know. This was our first one. If you think that we should do questions at the end and talk at the start, or whatever, like any suggestions at this point, this is a very, very new thing that we've decided to do. Just give us a shout in the comments on YouTube at Callum and One. Just Callum absolutely loves dealing with all of the social stuff.
I love getting interactions.
So yeah, Callum and One, Frey Needlecaster, our handles. I'll put them in the chat. Or Callum, no. Again, we're so disorganized that Callum doesn't have the permissions to post in the chat, which I need to sort out clearly before the next one. So yeah, let us know what you'd like to see more of, what you'd like to see less of. Apart from that, go forth and play around with this before our next episode, which will likely be next week.
Yeah, learn to break stuff.
Yeah, have a go in the Juno docs. Try launching your chain on your laptop. Have a play around with it. Have a play around with Kepler. When things break, let us know. If bits in the docs are wrong, let us know. And don't forget to like and subscribe. And we'll see you in the next one. And that's about smooth as a sign off as I can do.